We are ready to go, and we only have incurred a small delay of 7 minutes. So with a big round of applause, I'd like to introduce our next speaker, who will debunk some myths about removing CO2 from the atmosphere, who will explain to all of us which ideas are viable and which are less viable. And I believe that is the first time that we'll have a marine geologist on stage. So please give a warm round of applause for Maria-Elena Vorrath.
Thank you very much. The presentation is going to look somewhat different than planned, but you're probably going to get the content as well. We as humans are flying to the moon, we have cancer, and we make photos of black holes. At the same time, we're attached to things which are completely nonsensical, that are already debunked. And I have taken this photo from June of this year to show that we're still behind two fundamental errors, most of us at least. First, we as humans believe that we're superior to nature technologically. And second, a lot of us think that measures to mitigate climate change are going to limit our freedoms more than if we don't do this. And this image shows very clearly that the people who couldn't get out of their house this day perceive their individual freedom quite differently. Without air, without water, we cannot exist on Earth. Earth is demanding whether we're existing or not. In Hacking the Climate, it's about climate engineering and the question if this can help us out of the climate crisis. And before I start, I completely forgot that I'm going to have a science slam tomorrow, and that's the memes, sex and chemistry are going to happen tomorrow and not today. So now you know there's something to look forward to. I'm doing this whole thing. Why? Because I wrote my PhD over the ice in the Antarctic, and I realized, oh shit, there is no ice anymore. And if we're doing research, we're not researching nature itself, but only its destruction. My motto is don't cry, and that's why I started climate engineering. What is this about? What happened so far? In the last 150 years, we increased the carbon in the atmosphere 150%, methane 150%, and that increased the temperature by 1.2 degrees currently. With El Niño this year, we're at 1.5, and that has as a consequence that water is melting, and droughts and strong rains are happening 2 times more frequently, and heat waves 3 to 9 times more frequently. Climate engineering is nothing other than geoengineering. We just reframed it. Why? Because Hollywood has messed it up for us. There are a lot of Hollywood movies that show you a completely wrong picture what this is all about. The definition of Wikipedia is the deliberate and large-scale intervention by technical means in geochemical and biogeochemical cycles of the Earth. And I actually wanted to highlight geochemical. Geochemical is everything that deals with rocks, water, air, and also ice, and their chemical and how they are exchanging matter. The exchange with the living world, plants, animals, fungi, and so on, and how CO2 is bound by photosynthesis, or if rock is eroding, how the plants are taking that matter in. If you're interested, the story of climate science, then come to the Science Slam tomorrow. There are 2 fundamental differences in climate engineering. The first is the solar radiation management. It influences the balance of radiation in the Earth. It influences wind, it influences patterns of precipitation, And you can do this. This yellow thing on the slides, you can do that by putting aerosols into the air that produce clouds, or very simple by changing the color on the surface. If you make all the roofs white in a city, it'll be cooler in summer. Everybody who was looking forward to that, that's not what we're going to talk about today. It's about carbon dioxide removal, the reduction of CO2, taking it out, called negative emissions, because what we have put into the atmosphere is going to be taken back, and that actually takes care of the reason for the climate crisis, because CO2 is the main culprit of global warming. Methane is dispersing quite quickly in the atmosphere as opposed to CO2. It's more sensible to go for CO2, and also we understand the cycles of CO2 much better than the ones of methane. That means if you take CO2 out of the atmosphere, you're fighting the main reason for climate change. Why do we need net zero? Why do we need negative emissions? We often imagine that net null looks like this on the slide. We're reducing our emissions quicker than we increased them in the past, and then we're actually at zero. That's not how it works, unfortunately, because we always have emissions that we cannot possibly avoid from agriculture, from chemical industry, from the production of cement. That means even at the end of the century, there will be residual emissions that somehow need to be balanced to come to net zero. There are other carbon places that bind it, and they need to be thought as residual emissions as well, and they look like this. That means we're dependent on having a mechanism which creates negative emissions. The problem with this net zero strategy is that the brown area on the chart is CO2 that we are going to add to the atmosphere until we reach net zero, meaning the climate crisis will escalate. So it's much more sensible to take a strategy of reaching net zero much sooner. If you are looking at this graph, it would be in 2060, taking more CO2 out of the atmosphere than we put in. And that means the rise of CO2 concentrations is going to stagnate and then sink, get lower, and this would be the time when Earth is starting to cool down again. With this strategy, there is a chance that our descendants will have a cooler planet than we do. Basically, you have to differentiate between CCS and CDR. CCS was very present in the media because someone is sending the CO2 to Norway to have it pressed there, put it into storage. And the other strategy is to capture at the industrial plants the CO2 directly, which would be a strategy to avoid putting new CO2 into the atmosphere and thus mitigate industrial emissions. You could put this to a coal plant, but that would be stupid. But if you do this, you're slowing down global warming and make this brown area on the chart smaller. CDR means we're taking out the carbon that's already in the atmosphere and actively try to induce a cooling. Since this is way too simple, there is a hybrid strategy. If we take a product of photosynthesis like elephant grass and then use this to create energy and then do CCS at the plant that creates this energy, then we have CDR plus CCS, which would, for instance, be bioenergy. What CDR isn't also, it's not compensating CO2. The current concept of compensating CO2 means I emit, I throw money at someone else, that he does not emit CO2, and in some I added 1 ton of CO2 instead of 2, but the atmosphere will still warm because CO2 levels are rising. And we know since a long time that the CO2 certificates are usually fraudulent. It means I have less money and more CO2 than I intended. If we go for carbon removal, yes, I pay someone else, but in this case not for avoiding emissions, but for taking them back. That means I would have a net zero sum in the end, and I'm not going to influence the climate. And this would stagnate global warming, provided that this actually works as intended. That's for sure. And the best way, which we just saw, I don't emit anything. I also take CO2 out, have a negative balance sheet, and then we're cooling. Wonderful. How can we take CO2 out of the air? There are 3 methods, and it's 2-to-1 for nature. The first is something you know from school, photosynthesis. It's the classic. You have CO2, water, and solar energy, and the result is oxygen and stuff. And important to keep in mind is if I eat cake and I also photosynthesis is a cycle. What plants take out of the air, we that eat plants will digest and take it out again, and that means it's a big cycle. We know photosynthesis from vegetation, also from plankton, and a lot is hidden in the ground, in the soil, or it's concentrated in fossil layers. The second is not very widely known, but it's my area of expertise. It's the geochemical soil erosion, and it happens since the beginning of the Earth.
Oh, this doesn't look great at all. I'm sorry. When CO2 and water mix, then an acid forms, which is carbonic acid, and this attacks minerals. The minerals erode. It turns into magnesium ions, bicarbonate, among others, which is nothing else than hydrogen carbonate. This is on your bottles of mineral waters. If you look at the chemical analysis, it's dissolved stable carbon in water. It's non-toxic. There are people who believe it to be toxic, but that's not true. This can remineralize to a magnesium carbonate or a calcium carbonate, which is limestone, and this removes carbon from the air and from other cycles for thousands of years. If you don't enjoy chemistry, come to the Science Slam tomorrow. There's sex and chemistry at the Science Slam. The third method was invented by us humans. It's a direct air capture and direct ocean capture. We can separate molecules from each other, gas molecules. Nothing is happening here. We can filter a lot of air on the one hand. and have carbon dioxide docked to amino acids. We can do that many times. This concentrates CO2, and then we can store it by CCS somewhere. This plant is in Iceland, and the rock actually contributes to the remineralization. It's pumped into the rocks, and the CO2 becomes part of the Earth's crust. You can't do much safer than that. In the oceans, you can electrochemically decrease the pH of the water. You can restabilize the pH to that of the real seawater, and then the seawater that you've treated like this, it starts to equilibrate with the atmosphere and to capture carbon dioxide. Let's hack the carbon cycle. What is the carbon cycle? We have stored a lot of carbon in fossil resources. There's also land vegetation, but also permafrost and soils bind a lot of carbon dioxide. Soil actually contains more than 4 times as much carbon dioxide as all land vegetation. We often believe that trees do a lot for the climate, but the real champions are soils and permafrost soils. Lakes and rivers and coastlines are relatively small carbon pools. There is organic carbon in the sea. There's the atmosphere. At the beginning of industrialization, we had far less than today, which is 900 gigatons, which we have to remove to reverse industrialization. But the absolute champion is dissolved inorganic carbon, which is bicarbonate, which you find in mineral water, and the sea can store a lot of that. And if you imagine that we increase this pool by 1%, then we have removed 370 gigatons of carbon dioxide from the atmosphere, which is more than we've emitted during the Industrial Revolution. The potential is huge, but it's a cycle. So we've looked at the sinks, but the cycle works like this. We have the emission of fossil carbon. We have emissions by land use change, agriculture, forests that are burned. And this is removed from the atmosphere by the ocean and by capture on land, but half of that remains in the atmosphere as 5 gigatons of carbon, which makes the climate hotter and hotter. There is a small industry of climate engineering, and this removes 0.0003 gigatons of atmosphere from the of carbon from the atmosphere every year. It's as much as we emit in 21 minutes. So that gives you a sense of the scale. To hack this, we can do several things. We can reduce emissions. We can make the atmosphere capture more, and we can attack cycles, because tons and tons of gigatons of carbon are cycled in the atmosphere every year. And if you can change this and get some of that to flow into the earth instead, then we can improve our carbon emissions by a lot. There are lots of technologies and methods to do this. The first would be storing carbon in vegetation, and that's the classic. We plant trees, we re-establish moors, and if moors and swamps continue to start to grow again, then they're going to take carbon out of the atmosphere. We can improve forest management and make them increase their biomass. The bigger pool is storing carbon dioxide in the soil. We can store organic carbon in the soil through certain agricultural practices, by reducing or stopping plowing. Depending on who you ask in science, you get fans and critics. And there's this great idea of burying dead biomass, humans, for example. And we're now at the hybrid CCR-CDS. There are several ways of storing carbons as oil or gas in geology, which means we pump it into certain rocks where they mineralize or get trapped. And you have to know that the Earth's crust contains 99% of carbon on Earth. The atmosphere only contains 1% of global carbon, so the Earth's crust has a lot of room for additional carbon. You can store it in long-lived products. Storing it in e-fuels is completely silly, because it gets burnt again, it's back in the cycle, and it's very expensive to produce. You can store it as organic carbon in the sea by dumping biomass in the sea, or
the second would be blue carbon management. We're protecting the soils. It's also a very small pool. And now comes the winner. We are eroding rock on land or in the ocean, and then make sure that this big pool will just eat up a bit of carbon. The IPCC report has published a few numbers, what the potential of that is. These would be gigatons of pure carbon, and we also see that the yearly potential to get carbon out of the air, if those technologies are used worldwide, are quite different. The numbers differ a lot because we don't really know how well it's going to work. And also here, the increase of the ocean's capacity to buffer the biggest pool with 27 gigatons of carbon per year. You remember the graph that's decreasing? If we can make 10 gigatons of CO2, which is 7 tons of carbon, if we pull that out of the air, combined with reduction of emissions, we can make a net zero world. And 3 gigatons per year, if you do all that, that should work. So now let's get real. Now I have to hurry up, but I wanted to tell you what I'm researching about at the University of Hamburg. We didn't take it easy. We wanted to combine soil erosion with photosynthesis. The first would be increase the speed of erosion. Erosion is slow, and to speed that up, we as humans don't have 3,000 years worth of time. We need to solve the climate crisis now. Rock will erode quicker if you break it down. If you increase the surface of stone, that looks like this metaphorical picture. Erosion is also going quicker if it's warm, and if it is moist and sour. That means we put rock flour in tropical soil. And the great thing is you can buy this at every construction store, and it'll make your plants grow optimally. That means quicker erosion is natural fertilizer, and that makes this thing so very sexy. Plants make sure that CO2 is stored in the soil. That means a lot of CO2 is going to react with this rock flour, and the bicarbonate, which is a surplus here, will get into the ocean. The second would be biochar. Plant charcoal is created by warming up wood with no oxygen, and thus create charcoal and some oils and some gases which you can use to create energy. And in sum, the balance of this is positive. That means you will get extra energy, positive side products, and that biochar is used traditionally in the tropics to make soil fertile. You have a big surface that can charge itself with nutrients and with water. Traditionally, the whole family is peeing on it. There's going to be a bit of cow shit and the charcoal, put it into the soil, and that makes it possible to do agriculture in the tropics. This is an old agricultural tradition, and we're investigating this in CO2 boxes to check out, to simulate the higher concentration of CO2 in the soil. And we have so many synergetic effects. All of those are working hypotheses that we have through the combination of rock flour and biochar. I'm not going to go into this in detail, but we predict a higher CO2 extraction by doing this, but also having more resistant plants in the process. Well, what are we going to do with this? Well, when I decided to do climate engineering, I was attacked at conferences. What am I thinking to disturb the climate system? We first have to research it and understand it. And my answer was, what do you want to research? If I'm traveling by ship, I only see melting icebergs and microplastic everywhere, and that's not the world we want to live in. And we don't have another choice, because whether we research negative emissions or not, someone is going to use it. And if someone is going to do it, it's usually the fossil industries, and they really don't care about human rights or the environment. And my colleagues and me working on that, we do it because we know that sooner or later we are going to have to use it. And we think, let's better do it with independent research, independent money, and we need to risk manage in which fields you should not do this. That means it looks like we could solve the climate crisis with this by just taking out carbon from the atmosphere. And actually, we have the potential to take several gigatons of CO2 after 2050, Why after 2050? Because all those technologies are still very young. We need to watch it. Maybe it won't work if we put the flour together with the charcoal on agricultural fields. We might not be able to measure how much CO2 we have bound using that. And extracting carbon from the atmosphere only works if the emissions are reduced at the same time. And that would mean 90% of them, because if we only extract carbon, then the curve will look like this, and we are still emitting. We will have peak emissions, and our emissions will get lower somewhat by the end of the century, but we will still have a positive balance sheet, and that means that global warming will continue, and we might end up with 3 or 4 degrees of global warming. So if you extract CO2 out of the atmosphere, it needs to be reliable. There needs to be independent regulation, and we need to figure out who pays for this shit. And everything we do as humans affects the environment. Whether it would be planting a tree, or burying trees in the ground or whatever. That means we need to know what we're doing. This depends on resources. Some need a lot of water, some need a lot of energy. That means it could be a bottleneck for those technologies in the future. And we need societal acceptance. We need a broad front against disinformation. That's why I'm here. And we need a society which is knowledgeable, that cannot be abused by politics and the producers of oil. It's a huge business. They will want to buy into this. And politics likes to argue, hey, we can just go on as we did. Especially FDP and CDU, German parties, do this quite happily, and they want to promise that everything can stay as it is because we have the technologies, and that would be bullshit. I will get to the end. We can have a short discussion. I would like if we could focus on 4 small things. First, you cannot substitute reduction of carbon for reducing emissions. And those emissions should only be emitted if they cannot be avoided. That means flying somewhere is not something I should balance out through this. And you need many different parts. It's one piece of many. It's like the broom that will clean away the emissions at the second half of the century, but the rest we need to take into our own hands. Thank you very much for listening. I have 2 QR codes. One is a queer love story between a rock and SpongeBob, how to save the environment by reducing carbon dioxide, and the other would be the state of CDR. It's the current state of the CDR technology. Thank you. Happily, we still have a little time for a lively discussion and questions. People who are in the room, go to the microphones 1 and 2. Back there is 3 and 4. And until then, from the Signal Angels, are there any questions from the internet? No, there are none. Who wants to ask a question? May I use the hashtag 37C3 EI1 at the Fediverse. Quick question.
Are we sure that the increasing carbonate in the ocean is a problem?
The concentration of hydrocarbon in the ocean will rise so little by this that it will be lower than errors in measurement, but only if it's mixed throughout the whole ocean. We're researching a lot on that, also at an institute whose name I didn't get, how this also affects different marine organisms. Thank you very much. Microphone 4.
Thank you for everything. It's very interesting. Me and a lot of other people have no idea from chemistry, more informatic. What can we do as the technicians to help?
There is the problem that extracted carbon is calculated 2 or 3 times. So I have no idea of computer science, I might be wrong, but it's often said like, blockchain technology to trace every reduced ton of carbon, so it's not counted a second or third time. But other than that, everything around certificates, to ensure that this market, and it will be a market, because I do not have €1 million to just seed it somewhere, making sure that CO2 streams are calculated correctly, I think that is a big challenge. that could be solved via computer science. Thanks a lot. From the internet, is there a question so far? All right, then let's microphone 2.
Hello. How is it with the energy balance in your...
Basically, there needs to be a life cycle assessment. We need to see how the emitting process, like creating rock flour, and how much CO2 are we taking back. And this also needs to take into account how much energy is wasted. And only if the balance sheet of all of this is negative, we can declare it as a negative emission. There is one institute that did this calculation for rock erosions, for rock flour, and we do get a negative balance sheet. And for each ton of CO2 net, taking out of the atmosphere, there is a price of like €240 calculated by them. But this is a pilot project. Thanks a lot. Microphone 3, short question.
I'll make it short. I have a question to a very concrete page. Could you give me a source?
Can you take up that slide? And while that, we can ask for microphone number 1 with a short question. We're scrolling, and until then, microphone 1.
With me, it's nature-based solutions. In the IPCC, your solution, is your solution NBS fitting?
Before we're confusing everyone completely, the source. That has no source. I did that myself. So Mary is the source. Small applause. Well, that's just the concept. A visualization of the concept.
Okay, cool.
All right, cool. Now, nature-based solutions, IPCC report. In the IPCC report, they don't differentiate between nature-based and tech-based. It's biological, geochemical, and electrochemical, as far as I see, because if you go and pulverize basalt with a car, it's a technological solution, but the soil erosion that's happening in the soil is a natural process. That means we're mixing technology and nature with each other. We're using technical means to fasten up certain processes, but biologically and geochemically those processes are just natural, and that means we do not differentiate that way anymore. So I would say it's natural, but of course we're helping via technological means to get the rock burned down. So we would have the time for 2 or 3 questions. The shorter, the better.
Okay, thank you. I want to ask about the topics. Resource management. How many mountains do we have to pulverize to have a valid effect on our climate?
We have enough rock. That's the problem, is that maybe there's like houses on that rock. But we also have that problem if we do reforestation. Sometimes people are displaced from their land for reforestation. We have enough rocks. We have enough ocean to store it in there. The resources are there, but they're not available at every given point in time. Everything we do affects the environment. We need to compare apples with oranges here. Are we and make the trade-off which damages we want to have depending on the technology we use. That's very difficult, but fortunately in Germany there is a institution that is called sorry, I didn't get the name, and they deal with the societal and environmental effects of all of these things. Then we have another question from the internet. Signal Angel.
To realize one of these ideas, how much energy is needed? What kind of percent of the total human?
I cannot answer that question because it depends on the method. Direct air capture is costing a lot of energy. That's why that plant is on Iceland. And to ground down basalt or create plant fertilizer, that it only takes very little energy. Plant charcoal will produce extra energy, so that will be a process that even has a positive result, so it depends on the method.
Okay, alternative
All right.
Kühler.
Create of charcoal as an alternative career path.
Thank you. My question is there an optimal goal for reducing the CO2? Is there a solid term of where we are headed?
We're coming from 240 ppm, we're at 420 ppm in the air. And if you look back into the history of Earth, when was the ice shield of Greenland collapsing? It was 380, 360, those were the numbers that were in the room. You can't be sure. It could be that we already have irreversible damages by now and have some tipping points already, but it should be below 280. All right. Thanks a lot for this lively discussion. A big applause for Maria-Elena Vorrath, and we as the Translation Angels are signing off. Have a nice